In this video, I break down the solution for challenge number 13, Gatekeeper One of Ethernaut CTF, and this is part of a series of videos going through all the challenges in this CTF and talking about the solutions for them. So if you like this kind of stuff, you are at the right place. I also explained the reasoning behind all the solutions so that anyone can learn and do it themselves. So without further ado, let's move on to Ethernaut. And this is Ethernaut's page, and we have all the challenges here, and this is the number 13 here, right? So we also have MetaMask connected and so on. So if you have any problems doing this, or if you don't know how to do it, head over to the first video in this series where we talk about that and solve any common problems that occur, and we are so that you are good to go. And Gatekeeper One is this challenge. Let's click on it, and we have our challenge. To interact with the challenges, we need to open the console, and we should have something like this with all the level addresses and all that good stuff, and we are good to go. So what we have here, it's we need to make it pass the gatekeeper to register as an entrant to pass this level. So what are the gatekeepers? So we have three. These modifiers, usually modifiers in Solidity work in the way that everything that is in this function before this is executed before the function that we are calling, and anything after this will be executed at the end of the function call. So we have three gates, as you can see, by three modifiers, and the function enter receives this parameter, this gate key, which is 8 bytes, and needs to pass gate 1, pass gate 2, and pass gate 3. And if it goes all the way, we can register as entrant. So let's examine each gate on its turn. So gate 1 requires message sender to be different from transaction origin. So this is true when they are different when we have a contract calling a function. So if we call a function in a contract and that function calls this function, our address will be the message, the transaction origin, and the contract's address will be message sender, right? So they will be different. That's one possibility, right? So gate 1 is easy to do. We implement our own contract, we call a function in our contract, and that function calls this one. We are good to go. Gate 1, done. Gate 2 requires the gas left to be something, okay? This is not an easy one to figure out by calculating. So the easiest way would be to brute force it. So these kind of things usually work by brute forcing. It's just the easiest way. We could do all the calculations and blah blah blah, but come on, let's just. We are not that picky, right? And gate 3 has some calculations to do. So receives 8 bytes, and those 8 bytes are moved around, right? So first they are exchanged for a 64-bit uint. So here is the 64-bit as well, and then 16 and 32. So those have to be equal. So the last part and the beginning part, and this should be different. So the part of that has to be different, the same, the 32 bits, the first 32 bits of the 64 bits of the gate key should be different from the 64 bits of the gate key. So I see that we need to have a window in this key, and the transaction origin is also like our key, our account also joins the mix. So this will require us to do a bunch of bit manipulations and stuff like that, but it's not impossible, right? And we could compute the gate key for this gate. So there is a tricky one here with maths and bitwise computations, and there is a brute force, and this one is peanuts, right? So let's get our instance, prove in MetaMask. There we are. We have our instance so that we can use it later. We will have to implement a contract. So the easiest way to do this is to use Remix IDE. So we create here in the contracts a new file. Call it GATEKEEPER ONE. So there we are. And let's copy our code inside this. Okay, there we go. And now we need to create our attack contract. There we are. Gatekeeper One attack, because we can. And so with this, we are good to go, right? Let's, we need to store our victim, right? So the usual stuff, Gatekeeper One victim there, and constructor victim. Okay, so far so good. So we have our victim, and now we need to create a function to attack, right? Let's do it. There we go. Function attack. And this is to be public external. There we go. And this function will compute the gate key, and we'll brute force the entry due to the gas. So this gate 2. So in order to do that, I will paste some code here. It's easier that way. Otherwise, we would have to be writing all this stuff. So the computation for the gate key gets our key, our address, and computes this part. So the 160 bits of that, and translates it to a uint64, right? And to a bytes 8, which is what we need to send, and then cuts out this middle part, right? So that's the requirement for these two first parts. So it cannot be equal, right? So this is the computation for the gate key. Now, by calling from this function, we are already solving the gate 1, right? So gate 3 is done, and now we need to concentrate on gate 2, which is a brute force. So we do a for, and for 300 more or less gas, because we pass here the right amount, right? It's 3 times the value that they are dividing, and expecting the result to be 0, the left of that division. So we pass 3 times that value and plus 1 extra of 300, and we will eventually, on those 300 calls, one of them will go past this. So to call, we have to do it using the call function on the victim's address, so that we pass the right amount of gas, right? So we pass this gas, and then we encode the call, right? We encode the signature for enter with the gate key that we want to pass in, right? And then we just check for success so that we can break our brute force. Because if it's not successful, it will throw and the call will return false. And we will be able to continue iterating until we succeed, right? this is a brute force attack. It's simple. And the most tricky part was to compute all this byte shifting stuff and nothing more. This is our solution, and let's try it out, right? So to try it out, we need to deploy it on our Sepolia chain. So, and for that, we need this value. Let's copy and let's go to deploy the contract. So the attack contract with this address, and let's deploy it, confirm. There we go. We deployed the contract. We have here the attack function, right? So we can check the victim, should be the address of this contract, and we can do the attack, right? So let's do it. Let's attack because we can, right? First of all, before we attack, let's just check await contract dot entrant. So the entrant is 0 as expected. So there's no one entered the contract yet. Okay, so let's attack. Confirm our transaction, and and we were successful. So at least the function passed. Now let's check our entrant, and it's our wallet. So we were able to enter our contract with this method. So having a contract calling, having a brute force for the gas left, that we shoot more or less 300 gas up or down, so that we were able to pass it, and bitwise computation for this one, which was not very hard to do. And that's it, guys. So this is what we need to do for this challenge. So as you can see, it's not a big deal. It's an easy one. It seems very complicated because there's a lot of moving parts, but if you analyze it like that, it's actually not a big deal, right? Just some bitwise computations and nothing more. And yeah, let's check if we passed the challenge, as we always do, right? So let's go submit our instance to Ethernaut and confirm it, and and there we go. We passed the challenge, and as you can see, we are good to go, right? Gatekeeper 1 is done, okay? We were able to figure that out, okay? So hope you liked it. Hope you understood what we did. It was not very, very hard. And this always puts us thinking that, yeah, no matter how many gates we put in stuff, with the right motivation, it's always possible to find a way in, right? So hope you liked this video. If you did learn something, smash that like button and subscribe for more videos like this. We are putting videos all the time. And thanks for watching, and see you in the next video. Cheers. Bye-bye.